In this video, we'll be looking at some problems from 7.1, number 8, number 13, number 20. In this video, we'll be looking at some problems from 7.1, number 8, number 13, number 16, number 26, and number 38. Okay, some preliminary information. This is from page, from the beginning of 7.1, the Pythagorean identities. Cosine squared theta plus sine squared theta is equal to 1. This is basically the Pythagorean theorem. Remember, on the unit circle, cosine is x, so we're dealing with x squared plus sine is y. X squared plus y squared is, you can think of this as 1 squared the hypotenuse. This is the Pythagorean theorem, and these two are equivalents to that first one. Another important thing is the definition of even and odd. A function is even if f of negative x is equal to f of x. Graphically, it means it's symmetric about the y-axis, like y equals x squared, an even function. Odd, f of negative x is equal to negative f of x. We say it has symmetry about the origin. If you rotate this 180 degrees, it's the same thing. This is x cubed, roughly. It's odd. For our trig functions, the only even function is cosine in his reciprocal brother, secant. Cosine and secant are even, the rest are odd. We will need this substitution. Perhaps most importantly, you got to just have this burned into your skull. Sine is equal to 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Remember, this co-part does not have to do with this reciprocal situation. It's the idea of co-functions. Cosine and sine are co-functions. It means complementary. Secant and cosecant are co-functions, complementary. Tangent and cotangent are both co-functions and they're reciprocals, so that's kind of nice, but you must know these conversions. We're going to typically be on one side of this equality. That is, we want to be dealing with sines, cosines, and tangents, or cosecants, secants, and cotangents, generally. Okay. Number 8. Cosecant x plus cosine x times cotangent negative x. Alright, in general, if we have this trig function and we got a negative input, we're going to employ our definition of odd or even. Well, they're all odd except for cosine and secant. So I can change this cotangent negative x to negative cotangent x. And I'm going to put times multiply operator cosine of x, we haven't changed yet, plus cosecant. From here to here, I've just changed cotangent negative x to negative cotangent of x. Well, we can write the negative in front and deal with this operator and change it to a subtraction. So we have cosecant x subtract, that is negative 1 times this is negative 1 cosine x cotangent x. Well, we have this cotangent and cosecant and this cosine. Well, let's get them all on the same side. Let's get them all in the cosine sine tangent side. Well, cotangent is cosine over sine. Changing cotangent to cosine over sine. Still have our subtract cosine. Cosecant is 1 over sine. Alright, so now we have cosine times cosine is cosine squared. We have 1 over sine x subtract cosine squared x. Recall that when we say cosine squared x, we mean cosine of x quantity squared. Alright, so we have still our sine x here. Now we have the common denominator, so we can simply combine like terms or subtract in the top 1 minus cosine squared x over sine squared x. Anytime you have one of the functions squared and one involved, you're thinking that Pythagorean identity. Going back to our Pythagorean identities. cosine squared plus sine squared equals 1. Well, that's equivalent to subtracting the cosine squared on both sides. It's equivalent to this. So now I can make that substitution. One minus cosine squared becomes sine squared. So what I have is sine squared x over sine squared x. And something over itself is 1. So this crazy statement in the beginning is equivalent to 1. All right, number 13. I see in the numerator I have this 1 plus tangent squared theta. I'm thinking my Pythagorean identities. Even anytime we have any one of our identities squared and we're combining a 1 with it, or a couple of our identities squared added together, we're thinking our Pythagorean identities. 1 plus tangent squared theta, what is that equal to? 1 plus tangent squared is equal to secant squared theta. Let's go with that. Okay, so changing 1 plus tangent squared to secant squared theta. That's my numerator. The denominator is cosecant squared theta. Plus, here we have sine squared theta. And here we have 1 over secant squared. I'm going to write this as cosine squared. Not all the way, always, but in general, I'm going to shoot for the sine, cosine, and tangent side of the identities. I feel like we think about those better. Well, secant is 1 over cosine, puts the cosine in the denominator. Cosecant is 1 over sine, that puts the sine in the denominator. So this thing is equivalent to sine squared theta over cosine squared theta. Well, sine squared theta over cosine squared theta is tangent. All right. Plus, well, sine squared theta, cosine squared theta, that is our main Pythagorean identity. That's 1. Thus, sine squared theta, cosine squared theta is tangent squared plus 1. And we just saw earlier, 1 plus tangent squared is secant squared. This is secant squared theta. Number 16. Here we are asked to write this initial expression in terms of cosine. We want to make everything look like cosine. Okay, great. All right. Tangent is sine over cosine. Cotangent is the reciprocal of that, cosine over sine. Cosecant is 1 over sine. Okay. I could find a common denominator up top and add those together. That will often be a thing I'm going to do, but this time I'm going to just simply multiply by the reciprocal. I'm flipping over 1 over sine of x and multiplying by the top. So multiplying, flipping over 1 over sine x gives sine x. Multiplying that by my first term there gives sine squared x. Sine squared x over cosine x. Inverting, multiplying by the second one, the signs cancel to leave just cosine x. All right, I'm going to put this over 1. Now, I can add these two fractions together. I need a common denominator. This will be a common practice. In order to get a common denominator, the common denominator between cosine x and 1 will be cosine x. So I simply need to multiply this right expression by a special version of 1, cosine x over cosine x. This is just getting a common denominator. So bringing this down, we have sine squared x over cosine x plus cosine times cosine will be cosine squared x over cosine x. Again, you can see we have this Pythagorean identity. The denominator is cosine x, which is what we want. The numerator is sine squared x plus cosine squared x, so that's 1. This, the sum of these two, is 1. So we have 1 over cosine x. We've written it in terms of cosine x. All right. Now to problem 26. All right, we have secant, and we want to write secant in terms of sine. Well, let's begin by changing secant to its reciprocal brother, cosine. Secant is equal to 1 over cosine. Well, now we need some way to relate cosine to sine. The primary Pythagorean identity does that. Cosine squared x plus sine squared x is equal to 1. Solving for cosine, we want to take cosine and write it as sine. So solving for cosine here, we get cosine squared x is equal to 1 minus sine squared x. Taking the square root of both sides, we get cosine of x is equal to plus and minus the square root of 1 minus sine squared x. From this line to this line, we've taken the square root of both sides. Okay, now we see that cosine of x is equal to this. Cosine of x is equal to this radical expression, plus and minus this radical expression. I can make that substitution, substituting this in place of cosine. Thus, 1 over plus and minus the square root of 1 minus sine squared x. We are done. Number 38. All right, the instructions on these are to verify this identity. An identity is an equation that is true for all values of x. They're telling us this left side expression is equal to this right side. So now instead of just simplifying, we know exactly what our outcome needs to look like. We want to make this left side prove that it's equal to this right side. I will begin with my numerator, negative secant of negative x by definition of odd. Secant is, definition of even. Cosine and secant are even functions. Thus, secant of negative x is equal to secant of x over taking tangent of x and cotangent of x and writing them as their quotients. That is, tangent is sine x over cosine x, and cotangent is the reciprocal of that. Okay, this next portion you'll have to do a lot. We want to add these two fractions together, so we need a common denominator. Generically, the common denominator is always the product of the two denominators, so a common denominator will always be that. I can multiply these two statements together. Cosine x, sine x will be the common denominator. To get this left one looking like cosine x over sine x, I need to pick up a sine x, multiplying by sine x in the bottom and in the top. I could have more easily just written sine squared. I want to show this out though. This right side expression, we need to multiply by cosine x over cosine x, just a special version of 1, just like multiplying by 2 over 2 or 3 over 3. Thus, the denominator on both is sine, cosine. We see that common denominator. Sine x, cosine x. The numerator, well, this is sine squared x. This is cosine squared x. Again, we have sine squared x plus cosine squared x. That is 1. The overall numerator of the fraction, we still have that secant. Well, let's write secant as 1 over cosine. Secant becomes 1 over cosine. Now, inverting and multiplying. 1 divided by cosine x times sine x cosine x I'll show the inversion and multiply 1 over cosine x times, inverting the denominator, sine x cosine x over 1. Well, you can clearly see that cosine x cancels with cosine x to leave sine x. So we have sine x. We just need to somehow show that sine x is equal to negative sine negative x. Well, we can achieve that by our definition of odd. Again, a function is odd if f of x, we are odd, if f of negative x is equal to negative f of x. So sine of x is indeed equal to negative sine negative x. That concludes this video.